Hello creators and makers, this is the Random Engineer. Today we're going to continue with our series and doing some weldment design and some sheet metal design. So weldment design is basically a structural design, and sheet metal design is design done with sheet metal, where you usually use bending machines and punching machines and stuff like that. So in this case, we're gonna start by doing some weldment. So to go into weldments, you just do a part just like you would doing at any time. And up here in your tabs, you go right click and say weldments. As you see, there are plenty of other Solidworks tools that can help you design a little bit better for each industry. So we're going to click on weldments. As you see here, mine is already clicked, and you will have this tab right now. So what this tab does is it shows you the weldment features and allows you to work within a structural interface. So today what we're gonna do is just make a basic structure, and probably let's see how we go in the future. So to start, we're gonna do a sketch, and let's say we want we wanna draw that. So this is let's say 1 meter by 500 mil square. And when using weldments, it's better if you design on 3D. So right now I'm doing a 2D sketch, which is basically sketching on a plane. So I'm just gonna do that and make it for construction and get out of there. So now I have a 3D sketch right here, which you can also start doing with 3D sketch here. And we're going back to weldments and say 3D sketch. So in the 3D plane, you can sketch whatever you want in a 3D environment. So let's say you wanna design a circle. You can see here that the circle is being drawn in the XY plane. If you hit tab once, it's being drawn in the YZ plane. Then if you hit tab one more time, you can toggle onto the ZX plane. So whenever you change this, it allows you to draw in 3D, and by doing so, you can create more complex shapes. So going to weldment design, we're gonna click on the line, and just as we did with the circle, you can start creating what is called the frame of the structure. So right now we are drawing on the YZ plane, and we're gonna go up by a certain amount, and then keep drawing lines. As you see, I keep drawing on the YZ plane. And as we discussed before, you will also have all the other relationships between the lines and sketches and stuff like that. So I'm just gonna hold Control and click on all the lines and make them equal right here. So as you see, if I drag one, all of them will update automatically. And just as I did before, I'm gonna create a square, well, a rectangle in the ZX plane. So I'm gonna hit tab and say ZX. So that's gonna allow me to draw a square. Oh, that was the wrong square tool. So I'm gonna hit a corner rectangle and say ZX again. And this is where we're drawing now. So now if you click on the line, you will be able to see that you can create different relationships here. These are along the x-axis, along the y, or along the z. That means that if I click this along the z-axis, that means it will basically have the same orientation. But since this is a rectangle in the zx plane, that's already been done, so you don't have to define that. So we're just gonna create a 2 meter, 2.1 meter, maybe like that. And as you see, this is still in blue, so that means that this can change. And now I just drag the point and it completely defined the whole thing. So I'm gonna say 1 meter here, so it looks better. And oh yeah, don't forget, if you have any questions along the way, I will go back to my chat preview and you guys can ask me and I will try to answer you as best as possible. So let me know if I'm going too fast or if you need some other information from here. And yeah, that's how it works. All right. So yeah, we are doing this. So right now I'm gonna create a line, and I'm too lazy to go back to this, so I'm gonna use my wheel here. I have the lines here, so I'm just gonna go down, and as you see, I'm dragging this and I'm drawing in the ZX plane. That's why it's not creating a vertical relationship. But if I go tap, I'm drawing now in the XY plane, and I can go down, and it's going to create that relationship for me. So just to show you what I mean by relationships, I'm going to draw here. I'm going to say this line is in the X plane, sorry, X direction. And as you see, if I look it from the front, it's on the X direction. And if I look it from the top, which should be Control 6, no, sorry, Control 5, it's again in the X direction. And if I look it from the side, it's just going to be a point because it's in the X direction. So that's how that relationship works. If I delete this and put it on the Y direction, it's going to change it. And the same, if I look it from the front, it's in the Y. If I look it from the side, it's in the Y. And if I look it from the top, it's in the Y again. So that's how those relationships work. I'm going to keep creating lines, and I'm in the right plane right now, so it shouldn't be a problem. And as you see, Solidworks is creating a preview of a square to show you what line we are working on, I mean what plane we're working on. And if I go all the way down vertically, it's showing me in the mouse cursor a coincident relationship and a Y relationship. So if I click on that, if I click that line in this position, it's going to automatically create all those relationships for me. So I'm just gonna, I wanna do okay, so now there's something that you can see here. I wanna create a kind of a ladder on the side of the structure, and you may be thinking that like if I click on as it is right now, it may seem that I have indeed created a link between those two vertical lines. But since I'm working on the XY plane, you can see that it's got a 45-degree, an angular relationship in the mouse cursor. So even though it seems that I'm going in the Z direction, I'm really not. And I'm gonna click on that so you can see. So if I'm going in 3D, you can see how the line is not in this right orientation. So you have to be careful about where you're, in what planes you're working. So right now, if I click on tap again, I'm going to work in the YZ direction, and as you can see now, I'm going to click over there, and now the line is in the correct orientation. So that's something you have to be mindful about. So I'm going to create 4 lines again. Keep using my wheel. And there you go. So I'm going to say from there to there, there's about 300 mil. And from there to there, I want 200 mil. So that's it's going to completely define these 2 lines. And I just want to say now the separation between those. Okay. So that's one way to define it. You can change that however you liked it. But since you don't know, or if you don't know how much do you want, and you just want 4 steps along the way, you can just create lines like this. And as you see, I'm making them in the middle of all those lines. And I'm going to hold Control and click on all of them and say all of them have to be equal and for construction. So now it doesn't matter how big this is, all the steps will be, there will be always 4 steps and evenly distributed along the whole height of the structure. Just because these are always, the relationship that we've made is that all of these have always to be equal, no matter how it changes. So that's one way to define it. Other one would have been click on these lines and say I want this 200 and I want this one to be 200, and that's another way of doing it. Not really needed at all. So we have finished this basic design. We're gonna go back to it. So I was just out of the 3D sketch mode, and I'm gonna go structural member right here. So structural member feature, it just creates a profile along a line, and it allows you to define the end properties or the joint properties for those structural members. So I'm gonna click on that and say you can select the standard here. I'm just gonna go ISO and maybe a rectangular square tube and go the smallest one that we've got. You can also add more here, and I'm going to show you later. And you can transfer the material from the profile if you need to. So I'm going to click on these lines, on the lines that I've just chosen. And as you see, it's creating a square profile along the whole lines. So this is where groups come into account. You can create a new group. For example, what happens if you click on those lines and I click on this one? It's not doing it just because they don't have the same orientation. So you create a new group so that all the lines have the same orientation and the profile are the same too. And now that's our structure. Let's say I want to click OK here. I'm going to hide this sketch. And we've got our first structure. So that's one way of doing it. And now as you see here, this is not the best joint in the structure. So we're going to edit that. And you can do this within the structure itself, and this is where you can click on these purple circles and define what kind of joint do you want. So here you get a corner treatment, and you say you also can define the trim order. So the trim order, it just tells you which part you're going to cut first. So trim order equal 1, that means that this group will be cut first, and then this second profile will be cut second, and this one will be cut third. So if you go, maybe I want this one to be second and this one to be third, that influences in the way that it's going to get cut. Okay. And you can select the welding gaps for this if needed. So that's one way of making the connection between all the groups. And let's say this one. I want this one to be cut second. So I'm going to say this one will be cut first, and this one will be cut second. And as you see, the profile itself changes. If I say those two will be cut at the same time, it's going to extend this one. Let's just click OK so you can see what I mean. This body is cut so that everything is cut at the same time, and there's interference here, but that's just because this is a whole complete line, and there's no way that you could create the part without having at least 2 cuts. So that's why it's not doing it in the best way. But if I go something like that, you see this cut will be done second and this one will be done first, and that's why it's updating like this, because this one will be cut first and the other ones will be cut second. So that's how everything is getting updated. But that, since we don't want this, we're just going to leave it as it is. And probably all of the cuts will be sort of the same, but this one. As you see, I have just put all of them to be a cut and in the same direction, and everything is updating so that the part itself can be cut in one go, and everything updates automatically. So I'm just gonna change this one so that all of them will be the same, at least all the top parts will be the same. And just 2 more joints to go. And now we can click OK. So as you see, if you go here in the cut list, you have 14 bodies. If you go right click one of them and say isolate, you can look at it independently. And as you see, Solidworks has calculated so that the 3 that joined itself, it's done the best way as possible. This wouldn't be done in real life though, but that's just showing you the calculation properties of Solidworks. So since this is only 3D, we're gonna accept that. And another thing that you can see here is that Solidworks has calculated the parts that are equal and has created a folder for them. So it's just saying this folder has 4 bodies, which all of them are the same. So in reality, you just need you just have 5 shapes to define your whole structure. So that's one way of using SolidWorks Weldments. As we have defined here, this is a 1 meter tall frame. But as you see here, this endpoint is right in the middle of the weldment. So if I make a calculation between the bottom and the top part of the frame, I go evaluate, measure. It tells me that the Y direction it's 1010. So what happened? Since we have the square tube to be 20 by 20, that means the halfway of 20 is 10. And if we look at the sketch, we are right in the middle. So right in the middle plus 10 would be those 1010 millimeters that we got over there. So one way of fixing this is by creating another group, or you can define it a little bit better by, I'm just going to delete everything so that you can see what I'm going to do. So if I click on these lines, and you come here, down there, you can say locate profile. So locate profile will allow you to select the points that the line is going to follow, that the profile is going to follow along the line. So if I click on this one, you can see how the whole structure will be shifted in that point, and the same thing will happen in all the other points. All right. So I'm just going to click on here. Oh, okay. I'm going to create another group. I'm going to click these two lines, and in this case I'm going to locate profile in another line, so maybe just there. And these points can be defined at, within the whenever you create the profile. I'm going to have another video tutorial about where you can locate the profiles. So we are still using the same lines and we are still using the same profile, but as you see, we've already got a different result because this structure is shifted to the side of this line, of this structure. And if we keep going in groups, you can see how the locate profile feature, if I look it from the front, it shows the difference between them. So I'm just going to say locate profile and say this point, because that's going to tell the whole frame to be at the same height as the line that we chose before. So that's where groups come in really handy. And for these two, we're going to do pretty much the same. Just locate the profile. Just go to the left view and maybe here. Yeah. And go new group and finish it off with these steps. So I'm going to locate the profile and say middle, and everything updates nicely. So as you see, the whole ladder now it's in the inner side of the frame, and we haven't really changed the sketch that we already did. So in the case that you wanted to define your sketch completely, you can keep playing with the location of the profiles, so you can get a better result of and a better understanding of how your frame can work just by changing this one. And as you see, if we go here, we can keep changing the order of the cuts just by doing this. Okay, so now we can go into another, let's say another feature. We can do end caps, which are basically holes. I mean, you're gonna cover the holes on the sides of your weldments. So you can just say I want it on the inside, on the outside, or on the inner inside, if that makes sense. And you have a thickness ratio, which is defined by this. So this is the thickness. The thickness of our weldment is 2. And if I define this by 0.5, that means that it's going to be in the middle of the thickness. You see, if I look at from the front, from the top, you can see that's right in the middle of the thickness. If I go more, it's gonna be closer and closer to the thickness. If I go less, it's gonna be greater than the shape itself. So that's how the end caps work, and you can do a corner treatment, so you can fillet them and chamfer them depending on how you want to work. And this thickness is just the end cap itself. And now that you have defined them, you can just keep clicking on the faces that you want closed, and that's just going to define all your end caps. So you don't have to do much there. So I'm just going to finish this like so. Also, we're going to create some gussets. And for gussets, you just have to define the faces that it's going to be going into. Let's see if you can do that. Yeah. So you can just select two faces, just like I showed you. And here you can you can say if you want a polynomial profile or a triangular profile. And also you can say if you want a holder, and you just define the parameters here. It says here D1 shows you the first direction, D2 will be the second direction of the gusset, and thickness you can define it down here. And you can say if you want it from the center, or 5 mil from one side, or 1 mil from the other side. Sorry, 9 mil. And here you can select the location between those faces, so to one side, to the middle, or to the other side, or you can offset from one side, or offset from the other side, or offset it from the middle. And you can change the direction of the middle profile there. So that's how you define a gusset, and you create your support just there. And that's how you end up reinforcing the whole structure. So I think that's gonna be it for today's episode. Yeah, it might just be the end for today's episode. So I hope you guys like this video. Let me know if you have any other requests for tutorials so I can prepare myself ahead. Next time we're gonna go into more detail for Weldment profiles, and we have to really play about the trim extend feature and the structural member, where you can rotate your profiles and create new profiles and download some profiles. Because right as it is right now, I only have 2 standards, and I'm really limited in the amount of profiles that I can use. But I'll show you next time how to download all of them. And yeah, again, I hope you guys liked this video. If you did, please leave a comment, subscribe, share, and all that good stuff. This episode will be done will be uploaded to YouTube later on. And that's it. See you guys next time.